Good afternoon, everyone. How are you? कैसे हैं आप? JNV दहोद, JNV भावनगर. I hope in the previous class, am I audible? Let me just confirm. Just confirm by saying yes or no. Am I audible? My screen is visible to you. Okay. So I hope in the previous class, the questions related to Ampere's law were discussed. What is Ampere's law? I hope you have done that part in the previous class. So now in this class, what we are going to discuss, we are going to discuss the questions about current carrying loop, force between current carrying wires, and the torque on a loop. So we are basically dealing with the main phenomena is force on a current carrying wire, on which we are going to deal with the questions. So on that note, I will wait for further 30-40 seconds for the students to join, and after that we will start further. Okay. So there is a question on your screen. This is the first question of our class, and I will give you some 40 seconds to complete the question. 40 seconds to complete the question. You can start solving the question. After that, I will discuss the question as well. Bhavnagar, Dahod, and Buldana. JNV Buldana. Vishakhapatnam is also there. Okay. So are you solving the question? Be interactive in the class. Don't sit like without saying a single word. You can turn on your cameras as well. Good afternoon, JNV Vishakhapatnam. Good afternoon. So what is the question? There is a square loop. Or I will say the question is saying there is a square loop carrying a steady current, that means constant current I, and the magnitude of its magnetic dipole moment is M. I hope everybody remembers what is magnetic dipole moment of a loop is I into A. I into A or NIA if N is the number of turns. Now, what if I say there is a square loop? So first, let's draw a square loop like this one. This is a square loop. The side of the loop is A. Very good. And it has some current I. Very good. It has some current I, let's say I. Okay. And its magnetic moment is M. So can you write it as magnetic moment of this loop is I? And what is the area? The general formula of magnetic moment is I into A. Or you can say NIA. N is the number of turns, but number of turns are not here. This is only a single loop. So N is 1. So area of this loop will be I into A square. This is a square, so side is square. Let it be equation number first. Now they are saying if this square loop is changed to a circular loop and it carries the same current, the magnitude of magnetic dipole moment of circular loop will be. So now they are changing this and transforming it into a circular loop like this. If you transform this square loop in a circular loop, let's suppose its radius becomes R. And in the whole process, the length of the wire ultimately will be same. If the length of the wire is same, what you can write? You can write it as the length of circular wire is what? 2 pi r. And length of square wire or square loop is what? 4a. How 4a? The circumference is 4a. So you can get 2 and this can be cancelled. So radius is equals to 2a over pi. You can correct me if I am writing something wrong. If I'm making some calculation mistakes, then you can correct me. This is the radius of the square loop. So what will be the magnetic moment of the square loop? You can write it as, let's suppose for a circular loop, I am writing now. Magnetic moment is m dash is again is equals to I into area. Area of the circular loop is what? Pi r square. Pi r square. So you can write it as I into pi, and radius is what? 2a by pi square. That means 4a square by pi square. You can cancel out some basic things. Pi and this square can be cancelled. And listen to me again. This I into a square. I into a square is what? Magnetic moment of the square loop. That is m. So what is m dash is equals to 4 is remaining 4m over pi. This is your answer. Which option is correct? You can tell me which option is correct. 4m over pi. 4m over pi, option number A is correct. So what you can learn after this question, one thing that you can learn, that magnetic moment of a circular loop is I into A, or whatever may be the loop. If there is a loop, the magnetic moment will be I into A, where A is the area. This A is the area. Another interesting thing, if you don't know, then I will like to learn. I would like you to learn that magnetic moment is a vector quantity. You can learn this thing if you don't know. Magnetic moment m is a vector quantity. And if it is a vector quantity, it must have some direction. What is the direction of the magnetic moment? Look at me. Just look at me. Take your right hand and try to curl the fingers of the right hand in the direction in which current is moving. For example, if you see at this square loop, the current is moving anti-clockwise. Clear? If current is moving anti-clockwise, take your right hand and try to curl the fingers of your right hand in the anti-clockwise direction. And if you curl the fingers in the anti-clockwise direction, the thumb will be inside or into the plane of the screen. So that's how you can find the direction of magnetic moment. I hope this statement is also clear. Say yes or no. I will move further for the next question. Rajkot Shimoga is also there. Try to answer the questions. Okay, I am moving further. There is one more interesting question here. There is a rectangular coil. Dimension is given. 100 turns are given. Okay, just I'm giving you some 40 seconds to solve the question. You just read it by yourself and try to solve the question and give me the answer. Good afternoon, JNB. Yetapaka. In which state is this, JNB? YouTube family can also reply. Andhra Pradesh. Okay, very good. Anyone solving the question? Have you completed this chapter in your classes? Just confirm one thing. Have you completed this chapter in your classes or in the weekdays classes? Gandhinagar, Ahmedabad is present. Very good, Ahmedabad. Rajkot is also there. Gandhinagar, Dahod, Vishakhapatnam. Have you completed this chapter? Just answer this question, simple question. Have you completed this chapter in your schools, in your classes? Very good. So you can attempt the question. Now, what the question is, it says a rectangular coil. Okay. Carrying a current of 3 ampere in the clockwise direction is kept centered at the origin and in the XZ plane. So now, first of all, there is a coil. You can say this is the coil, which has some 100 turns and centered at the origin. Let's suppose this is the origin, this is our x-axis, and this is our z-axis. This is our z-axis, xz plane, they are saying. And there is a magnetic field of 1 Tesla along the x-axis. There is a magnetic field of 1 Tesla. Let's suppose magnetic field is B in the horizontal direction. This is magnetic field. If the coil is tilted through 45-degree about z-axis, now coming back to the topic, it has some current in the clockwise direction. So it has some current in the clockwise direction, that is I. This is the current in the coil. Now, one thing that you can answer is they are asking the torque on the coil. As soon as I see the term torque on the loop, one thing that will come in my mind, that torque is equals to M cross B, where M is the magnetic moment, B is the magnetic field, or you can say it MB sine theta. Clear? This is torque with some directions, actually. Now listen to me. What is the angle between M and B, which is denoted by theta in this particular situation right now on your screen? M is in which direction? Can anyone answer? What is the direction of magnetic moment? What is the direction of magnetic moment in this particular diagram? Can anyone answer? Be quick. Be quick in your answers. You can say yes or no as well if you are not getting. But be quick because we don't have the full day. Some new school has joined, so they must say present or what kind of thing they want. A. Someone is saying answer is A. Bhavnagar is saying option number A. Okay. So Bhavnagar, can you tell me one thing? What is the direction of magnetic moment of this coil? What is the direction of magnetic moment in this particular situation? Can you use your right hand, thumb, right hand, and the current is moving in this direction? You should curl your fingers and thumb will be inward. That means magnetic moment is into the plane, magnetic field is right side. So angle theta is 90-degree in this situation. Now the coil is tilted through 45-degree about z-axis. That means this is z-axis. Now you can see that if this is the JNV Bhavnagar, very good. Now, if this is the coil, I will say, let's suppose this is the rectangular coil as soon as shown in the diagram, and this is the z-axis according to our diagram. And if I tilt it by 45-degree about z-axis, it will be something like that. So the magnetic moment which was earlier in this direction, if I tilt it something, so the magnetic moment will also shift by 45-degree. So initial angle between M and B was 90. So new angle will become 45-degree. So what I'm saying, that new torque or after tilting torque will become MB sine 45. Just place the values. What is M? NIA magnetic field, and sine 45 is root 2. 1 by root 2 basically. You can put the values and you can solve. N is what? 100. Current is what? 3 ampere. Area is what? 5 centimeter into 2.5 centimeter. If you convert it into meter, it will become -4. Magnetic field is 1 Tesla divided by root. And if you solve this, you will get some decent answer. That will be your answer. And if you solve this, you will get something approximately 0.27. This will be your answer. So there is no problem. You can easily solve it out and you will get the answer 0.27. Very good, Bhavnagar. Your answer is correct. Moving further for the next question. This is the question which was asked in 2018 in the mains examination. So have a look at the question. You will again get some around 40 seconds to solve the question. For those 40 seconds, try to read the question and try to solve it out. And if you guys are facing any problem in any of the chapter, you guys can ask us so that we can arrange the special class for that and all your doubts can be resolved. You can just ask, discuss in your schools, discuss with the students, and you can just tell us which chapter or which topic you actually want to discuss. Otherwise, we are going in the same way. Today we are discussing the magnetic questions, discussion of magnetic effect of current. Next class we will be discussing some other topic like the earth magnetism or the bar magnet. We will be discussing in the tomorrow's class. So you can ask anything. Option number D. Okay. Who is saying option number D? JNV Gandhinagar. Very good. If you have solved it. Question says, the dipole moment of a circular loop carrying a current I is M, and the magnetic field at the center of the loop is V1. Okay, so first thing is there is a circular loop which has some current I and have a magnetic moment M. Okay. So let's just draw the situation first. There is a circular loop like this. It has some current I. Direction is not mentioned, so you can take any of the directions. Its magnetic moment is M and magnetic field at the center is V1. Clear? When the dipole moment is doubled by keeping the current constant, the magnetic field at the center of the loop is V2. The ratio of V1 upon V2 they are asking. Now coming back. Magnetic field at the center of a circular loop or circular loop is what? Mu naught I divided by 2R. Is this formula clear? Do you remember this relation? So this is the magnetic field at the center. Now they are saying that magnetic moment is given as M. So if you write the magnetic moment of this loop, magnetic moment is nothing but I into area. Area is what? Pi R square. Clear? Statement clear? This is the formula for magnetic moment. Now what I am saying, let's suppose this is loop 1 and there is another loop 2. This is loop 2. It has some magnetic moment 2m and current is same I. Current is constant according to the question. Now, if you say m1 over m2, if you say m1 over m2, what it will be? M1 over m2 will be r1 over r2 square. Is it clear? Because I and pi are constant, current is constant, pi is constant. So what is the ratio? M1 over M2 will be R1 over R2 whole square. Now let's see another thing. M1 is given as M, M2 is given as 2M is equals to R1 square by R2 square. M and M can be cancelled. So you can say that R2 is equals to, I'm doing in one step, that is root 2 times R1. Is this step clear? R2 is equals to root 2 times R1. Is this statement clear? Now, they are asking the ratio of B1 over B2. You can again see that on the first equation. I am coming back to the first equation. You can see that mu naught is a constant term, I is a constant term, and 2 is a constant sum. That means B is reciprocal to R. So you can write it as B1 over B2 is equals to R2 over R1. Clear? And what is R2 over R1? You can get it from here. R2 over R1 is root 2. So this is our correct answer, which is option number D. Very good, JNV. I just forgot the name. JNV Gandhinagar. Very good. Correct answer. Root 2. Very good. Rest of the class, rest of the students, are you getting the situation? What's happening? As soon as I find that magnetic field is depending on the radius, and the question says magnetic moment is doubled, keeping the current constant, that means radius is also changing. So I got the second radius and I will get my answer. Any doubt? Or should I move further? Okay. Moving further for the next question. Are you writing anything or just letting it be? The next question on your screen. Again, I will give you some. This is the easiest question. I will give you some 30 seconds for this. Jalgaon is also there. Okay. Option A. JNV Changlang is saying option A. Okay, let's check. Anyone else? Bhavnagar, the Horde. The Horde is saying 0. Okay. Anyone else? I have two answers. One is saying 0. Okay, let's try to solve out the question. This is the question. You can imagine the, I will say, force between two parallel wires. This kind of question it is. Option B. Option B is answered. Okay, so I have almost 3 answers. And let's check who wins the race. JNV Jalgaon. Okay, so let's start the question. First of all, there are 4 sides. So what is my task? I will calculate force on each side and then add them in the according to the vectors rule. That will be my answer. So if you can see that I am naming the sides, let's suppose this is side 1, this is side 2, this is side 3 for me, and this is side 4. This is the loop which has 4 sides. Now I am asking just one simple question for you. If I want to calculate force on this first side of the square loop, who is the source of magnetic field? This I1 is the source of magnetic field. What is the direction of magnetic field created by I1? Just answer me one simple question. What is the direction of magnetic field created by I1 in this region, in this whole region of square loop? what is the direction of magnetic field? Are you getting my question? So you should answer quickly. 1, 2, 3, 4, 5, very quickly. Nobody is answering. Without knowing that, you can't solve the question. What is the direction of magnetic field created by I1? Into the plane. Very good. Okay. So magnetic field is into the plane. Now coming back to the side one, if you see at the side one, what is the direction of magnetic force? Use your right hand thumb rule, IL cross B, and you will find that magnetic force is in this direction. This is F1. Similarly, on second side, if you see, the force will be in this direction, F2. Similarly, this is F3, and this is going to be F4. Clear? Now look at that F2 and F4. The magnitude or the variation of magnetic field in the side 2 is similar to that of in side 4. That means side 2 and side 4 will have same magnetic field, or the variation of magnetic field is same, and the side and symmetry is same. So F2 and F4 can be cancelled. What I am saying that F2 and F4 will cancel each other because they are equal and opposite, will cancel each other. Now, what are the force remaining? F1 and F3 will be remaining. So let's calculate F1. F1 is what? Mu naught over 4 pi 2 I1 I2 divided by the separation. Separation is what? A into length of the wire is also A. So you can cancel this thing as well. So this force will be mu naught by 4 pi 2 I1 I2. This is the force. Direction is indicated in the diagram. So I am not indicating the direction again. What is F3? F3 is what? Mu naught over 4 pi 2 I1 I2 divided by the separation of third wire is what? This separation is 2A. So you can divide by the separation 2A multiplied by the length of the wire, which is A. So A and A can be cancelled. So what it will become? Mu naught by 4 pi 2 and 2 can be cancelled. That is I1 into I2. So you have two forces, F1 and F3. So net force is what? Net force F is equals to the vector sum of all the forces F2, F3, and F4. Out of which I have already told you that F2 and F4 will cancel each other. So F2 and F4 will cancel each other. What it will be? F1 and F3. The force which is in the right direction, I am taking it as positive. That means this is going to be positive. The force which is in the left direction, I am taking it as negative. This is the sign convention that I will prefer. You can choose any reference, any sign convention. So if I write it according to the sign convention, what it will be? F1 is positive. So this is 2I1 I2 minus I1 I2. So what it will be? Mu naught by 4 pi I1 I2. And the answer is positive. Answer is positive means right. This is the right direction, or right direction means it is repulsive. So which option is correct? The force is repulsive. Along with that, mu naught by 4 pi I1 I2. Mu naught by 4 pi I1 I2. This is the correct option. Repulsive. That means option D is correct. Nobody is correct. Clear? If you have any doubt, you can ask. If you have any doubt, you can ask. Otherwise, I am moving further. Moving on to the next question. Again, you have some 30 seconds to answer the question. Anyone? Okay. So just read the question. Rectangular loop is given. Some sides are given. Different orientation as shown in the figure. What there are a lot of orientations of the loop. If there is a uniform magnetic field in the positive z direction, uniform magnetic field in the positive z direction, in which orientation the loop would be in stable equilibrium and unstable equilibrium. Okay. Coming back to the question. Coming back to the question. For that, I will tell you two punchlines. One is magnetic force before writing this thing, I will tell you one thing very interesting. What is the equilibrium? Equilibrium, if I talk about, there will be two situations. One is the net force on the body must be zero and the net torque on the body must be zero. This is the condition of equilibrium. Clear? Equilibrium, any kind of equilibrium, these two conditions must be satisfied. Now, if I say, what is first situation? The first situation is the net force. I hope you remember this line. On a loop in a uniform field is always zero. Now just check in the question. The field is uniform. The field is uniform. That means first condition is already satisfied. First condition is already satisfied. You don't need to worry about that. Now, second condition, if I say torque will be zero. For torque, what is the formula of torque? Torque is what? mb sine theta. Do you know that? I have discussed this formula before. So torque is mb sine theta, and this torque will be zero. Torque will be zero if theta is either 0 or 180 degree. And theta is 0 or 180 degree. If theta is 0, everybody remembers from electrostats, if theta is 0, this is known as stable equilibrium. And this is known as unstable equilibrium. Now, what is your task to do in this question? Your task is to find the angle between magnetic field and magnetic moment. Clear? Your task is simple. Magnetic field and magnetic moment, you need to find the angle. Option B, you are saying. Okay, who is saying option B? JNV Bhavnagar is saying option B. Okay, let's move. Now, coming back. Rest of the class, is the statement clear? What I was saying? Now, one more thing. Magnetic field is in the Z direction. Magnetic field is given in the Z direction. Someone else has replied. Rajkot is saying option C. Okay, we will discuss it. Magnetic field is in the Z direction. So, in which direction magnetic moment should be for angle to be 0 or 180? Everybody will say magnetic moment must be in Z direction, either in positive Z or in negative Z. So, if you can focus on one more thing, I'm just teaching you like a way that you can understand the things very properly. M must be in Z direction, and magnetic moment is always perpendicular to the loop. So, for which loop magnetic moment is in the Z direction? You can see that in option number B, magnetic moment is in the Z direction like this. This is magnetic moment. And for option number A, magnetic moment is outward. Option number C, you can see magnetic moment is in the left direction. And in option number D, magnetic moment is in the downward direction. So you can clearly see that in option B, the angle is 0. And in option D, theta is 180. So this is stable. This is unstable. So which option is correct? B is stable, D is unstable. B is stable, D is unstable. B and D respectively. Very good, JNV. Who was correct? JNV Bhavnagar, your answer was correct actually. JNV Bhavnagar. Very good. The winner of the round. Moving to the next question. ये इतना पक्का JNV इतना पक्का is this question clear? Okay, so this is the next question on your screen. This question needs some 1 minute time, and I'm going to wait for 1 minute. Option D, JNV Gandhinagar is saying option D. Okay. Rajkot is also saying option D. Guys, can you turn on your cameras so that I can see your classes for few minutes? Can you turn on your cameras? Are you taking classes on the laptop or what? Jalgaon is saying option B. Okay. So we will find out soon which option is correct. So are you guys watching it on the projector screen or the laptop? What kind of uh, instrument you have to watch the classes? Okay, I hope I have given you ample amount of time. So let's start with the question. What it says, an insulating thin rod projector. Okay, everyone has projector. Insulating thin rod of length L has a linear charge density, something given as this. The rod is rotated about an axis passing through the origin and perpendicular to the rod. Okay, so first of all, just draw the rod. Let's suppose this is the rod. Clear. And about the axis passing through the origin or the center, like this one, this rod is being rotated. This is the axis. You can say perpendicular into the plane. If the rod makes n rotations per second, okay, then the time averaged magnetic moment of the rod is. Now look at that. Can you see that this rod has some charge density? This charge density is given as rho is equals to rho naught L by X. Sorry, X by L it was. It was X by L. Rho naught X by L. This is the charge density of the rod. Now, let's suppose this is the rod and it has some charge. Now, if this rod rotates, can you see that it is forming some current loop? And if it is forming some current loop, there must be some magnetic moment as well. So that magnetic moment I need to calculate. Are you getting my point? The first thing is, if the rod is charged and if it rotates, then you can see that charge is also rotating. And if charge is rotating, it will create some current. So due to that current, there will be some magnetic moment. That magnetic moment I need to calculate. Now, charge density is not uniform, it varies with the distance. So what's my first task? I am taking some very small element of length dx on the rod. And let's suppose it is rotating like this with some velocity omega, angular velocity omega, at a distance x from the origin. I have taken some small element. So what is the charge on this small element? I will say the charge on the small element is dq is equals to rho into dx. This is the charge. Rho is what? Rho is given as something like this. So this is going to be the charge on the this small portion dq. This small portion has charge dq. So if this rod is rotating, can you focus on that this very small element dx is also rotating in the circular path, or the radius of the circular path is x. So it will form a current loop. So what will be the current in that loop? I am writing that current here on the next slide. What will be the current? Let's suppose current is di. What is current? Current is what? Charge di, or I is equals to delta q over delta t. I hope you remember that. So what is the amount of charge? Dq over time. So I am just dealing with one time period. In one revolution, I am dealing with, and in one time period, which time period is t, or you can say dq. You can place the value of dq as well here. dq is what? rho into dx. This is dq. Can you see that this is 1 over t, and 1 over time period is nothing but frequency, and frequency is given something n rotations per second. This is what frequency multiplied by n. This is the current formed in this loop. Clear? Now the value of rho you can also place. So di will become rho naught x by L dx, and this n I am writing here. This is the current. If this is the current, then what will be the magnetic moment of this loop? You will say magnetic moment of this loop. Let's suppose it is denoted by m. So very small magnetic moment of this loop, dm, will be, what is magnetic moment? I into a, di into area. I is what I am putting the value, n rho naught by L x dx. This is di. Area is what? Pi. And if you see that this will be the circular path for this small element, what is the radius of the circular path? You can see x. So area is what? Pi x square. This is the magnetic moment of this small element. If this is the small magnetic moment of small element, for complete magnetic moment, you can integrate it. So for complete magnetic moment, I am integrating it, and complete magnetic moment m will be integration of dm. And if you can put the values, you can take the constants out of the integration sign. I am putting this value of dm, and what are the constant? N is a constant, rho naught is a constant, L is a constant, and pi is a constant. I am taking these constant outside the integration. So that is n rho naught by L and pi. What it will become? Integration. This is x square, this is x. So it is x cube dx. From where to where? From 0. What is the length of the rod? Is L. So limit is 0 to L. Till now, if you have any problem, you can ask. So now the task is to integrate it. M will be, this is n rho naught by pi by L. And what is the integration? X cube. That is x raised to the power 4 by 4. Limit is 0 to L. And if you put the limit, it will become n rho naught pi by L into L raised to the power 4. So what will be the final answer? M is equals to n rho naught pi. There is 4 as well. N rho naught pi L, and this is cube, L cube by 4. This is the magnetic moment, and which is correct option? N by 4 pi rho naught L cube, pi rho naught L cube. This is option number D, which is correct. Some students got the answer correct. Gandhinagar, Rajkot got the correct answer. Very good. And well tried by Jalgaon. Well tried, Jalgaon. Now you can ask me any point in this question. If you face any problem, what is the procedure that I have taken? If it is clear, you can say yes or no. If it is clear, you can say yes. If it is not clear, you can say no. I will repeat it once again. Otherwise, I will move further. Just be responsive. I hope it is clear. Am I audible? Am I completely audible? So moving further. Okay. Yes, sir. Next question on your screen. Very good, Jalgaon. You again have some 40 seconds to answer the question. Simoga, Vishakhapatnam, you two are very much silent, not answering, not participating in anything. JNV Anand. Okay. Coming back to the question. Anyone has some answer? I hope we are done with the time right now. You will have another class. So you can take this question as your homework and complete it in your homework. And we will discuss it in next class, or that is in tomorrow's class. Option 2. Option 2, that means towards negative y-axis. Okay, Gandhinagar, this is not the right answer. This is not the right answer. No problem. Do it in your homework and we will discuss it in the next class, that is tomorrow. Till then, take care. Bye, everyone. Negative x. No, bacha. It's not in the negative x. Option 4. Option 4 is correct. Rajkot. Option 4 is correct. Okay. Bye, everyone.